In order to solve this question, we need to use the whole idea that angle COA, we call that a central angle. So angle COA, it's a central angle because it's made off of the radius. So angle COA is going to equal 2 times angle ABC. So this is one of the properties of circles that you have to use in order to answer this question. So anytime you have an angle that's subtended off the same arc, so the arc that we're talking about here is AC, and you'll notice in the angle notation we have an A and we have a C. We have an A and we have a C. So the fact that it's subtended off the same arc, you will always end up with this relationship. So if we knew the central angle right here was 45 degrees, that would mean that angle ABC would have to be 22.5 degrees. Now the question is, using the information that's given, how do we figure out what the size of this angle is? There's two ways you can do this. The way that it's set up in this question, we know that sine of theta has to equal the opposite, which is 6 over 20. So then you can work it out by doing theta equals sine inverse 0.3. And then that will give you your value of theta. The other way that you could do it is using properties of triangles. So if that one side is 20, that means this is also 20. So for triangle ACO, we have all three sides. Anytime you have three sides in a triangle, you can always determine the angle by using cosine law. So in this case, we know that the cosine of angle O is going to equal 20 squared plus 20 squared minus 6 squared all over 2 times 20 times 20. So this is a rearranged version of the cosine law. The key to this question is once you get your value of theta, you need to remember to cut it in half because this represents half the size of the, the angle you're looking for is half the size of the central angle. So either one of these methods work. You just need to remember your trig ratios or when to use cosine law. The final question on this assignment is looking at this here. The arrow for the radius, so EO and EF are both 6,387. We know the distance to the satellite is 30,250. We want to know what percent of the Earth can the satellite see. So we're looking for the length of that red arc in order to figure out the percentage. So if we know what that red arc percentage is, we can figure out the answer to this question because the whole circle has 360 degrees and we know the radius, so we can figure out the circumference. So the key to this question is figuring out what this central angle is in here. So we're going to have to use trig again. So we know that in this particular case, we have the adjacent. So cosine of theta is going to equal, if I'm looking for that, so 6,387 divided by 30,250. So that will tell me what the angle is. Once I know that angle, I need to double it so that we can find so we're looking for angle EOF. So that'll be 2 times the size of that angle. From there, the percent is going to equal 2 theta over 360 degrees times 100. And then you also need to calculate your circumference, which is 2 pi r. So hopefully that's enough information to help you be able to put your pieces together to solve the question. If it's still not working, please let me know and I will try something else.